Hi, a new video with hybridization. Last video, we discussed about hybridization of central atom in the case of neutral molecules. Here, if I take cationic species, how to find out the number of electron pairs? Number of electron pairs. Already discussed number of electron pairs, nothing but sigma bonds plus lone pairs only. Why? Because hybrid orbitals can produce sigma bonds. So your surrounding atoms plus lone pairs we have to know. Lone pair is nothing but unshared pair of electrons that already discussed unshared pair of electrons. Right? So if I take a cation, same like the formula what we discussed earlier for neutral molecules, group number we have to take. Along with the group number, we have to take monovalent atoms which are connected to the central atom. Monovalent atoms already discussed about monovalent atoms, nothing but hydrogen or halogens like that we can take. Minus charge magnitude of cation. So whatever the cation is there, that cation charge magnitude you have to take, and that charge magnitude you have to subtract from the group number plus monovalent atoms. So then formula of hybridization for central atom. In the case of cations, you will get, if you want example, I can take example, very simple example, that is ammonium cation. So in the case of ammonium cation, if I want to find out hybridization of nitrogen, I want to find out hybridization of nitrogen. What you have to take the formula, number of electron pairs. Number of electron pairs, nothing but sigma bonds plus lone pairs. So sigma bonds plus lone pairs. So group number of nitrogen is what? 5. Monovalent atoms are 4 divided by, minus 1 is the particular charge magnitude on the cation divided by 2. Then you will get 8 by 2, which is equal to 4. Surrounding atoms are 4 and the lone pairs are 0. Therefore, sigma bonds, nothing but surrounding atoms. Unshared pair of electrons, nothing but lone pairs. Lone pairs in this species is 0. Finally, the hybridization you will get 4 electron pairs, nothing but sp3 hybridization. A simple. In the case of central atom, we are calculating hybridization. That means whatever the sigma bonds and lone pairs are there, those sigma bonds and lone pairs belongs to the central atom. It does not belongs to the surrounding atoms. If you want the structural data, I can write the structural data like this. Nitrogen is surrounded with 4 bond pairs. There is no lone pairs at all. So you will get tetrahedral geometry. Earlier, I did not discuss about geometry of the given species. Here I can discuss about geometry of a given species. Same like this earlier molecule, in the case of neutral molecules also, I can discuss geometry of the given molecules. Right? So if I take any other example without monovalent atoms, so let us take nitronium ion. Nitronium ion. Don't feel I'm taking like a class. So nitronium ion. Nitronium ion, in the case of nitronium ion, what is the hybridization of nitrogen? If anybody asked, hybridization of nitrogen if I want to find out, then what we have to take? Number of electron pairs. Here also I can take number of electron pairs, nothing but sigma bonds plus lone pairs. Sigma bonds nothing but we have to take surrounding atoms plus lone pairs. So here group number is 5, no monovalent atom 0, cationic charge magnitude is 1 divided by 2, then I will get 4 by 2 which is equal to 2, nothing but sp hybridization. That means nitrogen undergo sp hybridization. So what is a structure? How can you define the structure? That means if oxygen is there, simply I can take only sigma bonds. After that, if you have any idea about the combining power of oxygen or the valency of oxygen, how many bonds it may take place, simply you can write the original structure of NO2 nitronium ion. This is nitronium ion structure which is having linear geometry. That means not only the formula of electron pairs tells about the hybridization of central atom, it tells about lone pairs, it tells about bond pairs connected with the central atom, and also tells about the geometry of the given species, whether it is a cationic species or anionic species. So I'll give a question, you try hybridization of phosphorus in PCl4 plus ion. Or sir, what is a hybridization PCl4 ion? What is its geometry? Everything once you try. So I'm not giving data about this cation. I'm going to take for anions. Let us take, if I want to find out for anions, what is the number of electron pairs formula? Number of electron pairs. Number of electron pairs nothing but again sigma bonds plus lone pairs. Sigma bonds nothing but surrounding atoms, unshared pair of electrons. So what is the formula to find out central atom of anions? Again same group number we have to take, group number of the central atom plus monovalent atoms which are connected, monovalent atoms which are connected plus anionic charge magnitude. Divided by 2. So your writing is not good. I have to take Venkatraman and Co. book for writing or copywriting books. So if it is understandable, once you comment group number plus monovalent atoms plus anionic charge magnitude, I want to go to take one example. Sometimes whenever you're reading inorganic chemistry, they will give solid PCl5. What is the hybridization of anionic species or hybridization of phosphorus in anionic species of solid PCl5. That means if I want to find out the hybridization of phosphorus is anionic species of solid PCl5, first of all we have to know that in the case of solid PCl5 can exist as a dimer. So dimer is nothing but it can exist like PCl5 whole taken twice. That means it can write like PCl4 class. Earlier I gave one example to you, and PCl6 minus. So here anionic species one phosphorus anionic species is there, one phosphorus cationic species is there. If I want to find out hybridization of phosphorus in anionic species, I have to find out number of electron pairs. Number of electron pairs nothing but sigma bonds plus lone pairs. The group number is 5. Monovalent atoms are 6. Anionic charge magnitude is 1 divided by 2, that is 12 by 2, which is equal to 6. Therefore, here the surrounding atoms are 6, lone pairs 0. Therefore, 6 sigma bonds are present. So, 6 sigma bonds, 0 lone pairs, nothing but the phosphorus undergo sp3d2 hybridization. If you want geometry of that PCl6 minus, simply we can take geometry surrounding 6 atoms. We have to write surrounding to the phosphorus like this. So there exists octahedral geometry. See, so that means here we are discussing or we are thinking about hybridization, and also based on the hybridization, simply we are getting the structural data also. Sometimes based on this, if I know the structural data, I can say the molecule is polar, non-polar. It shows permanent dipole nature or non-polar molecule. Different things are there. Those particular concepts also we can cover based on this. So this is example. One example, I want to find out hybridization of phosphorus. If I want to find out hybridization of phosphorus, or sorry, hybridization of the central atom, which is involved with divalent or the atoms with more than one valence. That means if I have no dipolar, if I don't have monovalent atoms, then in the given species, if I want to find out hybridization, let us take, I want to find out hybridization of sulfur in sulfate ion. Here, sulfur is central atom, oxygen is a divalent species, therefore there is no monovalent atoms here. Therefore, we have to find out number of electron pairs first. Number of electron pairs, nothing but group number, that is 6. Monovalent atom 0 plus charge magnitude of anion is 2 divided by 2. Then I will get 8 by 2, which is equal to 4. Surrounding atoms are 4. Lone pairs 0, therefore sigma bonds are 4 lone pairs, which is equal to 0. Finally, you will get 4, nothing but sp3 hybridization of sulfur. So I need the structure. What is the structure of sulfate ion? Simply take 4 oxygen surrounded 2 sulfur with 2 minus charge. Then based on the valency, we can put oxygen connected with 2 bonds, sulfur connected with 6 bonds. Therefore, 6 bonds satisfied. So oxygen is connected with only one single bond. Then you have to write 2 lone pairs. Oxygen is connected with 2 bonds. Then you have to write 2 lone pairs. Therefore, the geometry is tetrahedral geometry. So that means this concept tells about how to draw the structure. Sometimes we can write the Lewis dot structure also. We can write sometimes original structure also. Once if you know the hybridization, based on this concept, we can calculate the formal charge, we can calculate the hybridization, we can calculate the lone pair of electrons on the central atom, we can calculate bond pairs connected to the central atom. what may be the structure. Based on the structural data, we can say the dipole moments, polar or non-polar molecules concept, everything we can say, right? This is about anionic hybridization. For in the case of anions, how can we calculate the hybridization of the central atom? And for the case of cations, how can we find out the hybridization of the central atom? So this is a complete description about the hybridization of central atom for cations, anions, and neutral molecules. Earlier, I discussed about the neutral molecules. In this video, we have the information about cationic and anionic species. This is only for inorganic species. What are the inorganic compounds are there? Discussed about this. If you want organic compounds, we have to follow other method. What is that method? We will discuss in the next video. Right? Thank you.